So let's say in this potential energy graph here, and the question says, identify all equilibrium points on this potential energy graph. Additionally, identify if it is a stable or non-stable equilibrium point. To start, the above graph represents the potential energy of a system, U of x, as a function of position x. But how do we identify equilibrium positions? An equilibrium position can be defined as the position x where no force is acting on the object. And we know that F is equal to negative du over dx, where U is the potential energy. So from this equation, this means that the force represents a negative slope of the potential energy, since in general, slope is equal to rise over run, which is equal to the change in y divided by the change in x. And in our situation, y is equal to u, since the y-axis on our graph is the potential energy. So slope is going to be equal to du over dx, and if we compare it to our force equation, we can see that it's the same with a negative sign. So if we equate these two terms, force is equal to negative du over dx, which is equal to negative slope. And we know that force is equal to 0 at the equilibrium. So if we plug in 0 into the equation, we get that the slope is equal to 0. So this is going to be the condition on the graph for when these equilibrium positions occur. If we look at the graph here, we can look at when the slope is going to be equal to 0. That's going to be at turning points, so we can identify it like so. Draw the tangent lines of the curve. They're horizontal lines at these points, which means that the slope is 0 at these points. So we identified all the equilibrium positions, x1 to x4, but which are stable and which are unstable. So for stable, a stable equilibrium occurs when the object is slightly displaced to either side. The force pushes it back towards equilibrium. Take this example here of this random potential energy function. This is the equilibrium point. If we displace it a little bit to the left at point x1, slope is negative. We know that the force is equal to negative change in potential energy equal to the negative slope. So if the slope's negative, the force is positive, and so that's going to point in the right direction towards the equilibrium position. If we displace it to the right slightly at point x2, the slope is positive, so that means the force is going to be negative, pointing in the left direction towards the equilibrium. And so we can see that this is a stable equilibrium position because slight displacements both push it towards the equilibrium. An easy way to find the stable equilibrium position is it corresponds to the minimum points on the graph. For unstable equilibrium, this occurs when slight displacements from equilibrium cause the force to push the object away from the equilibrium point. Slight displacements to the left, x1, the slope's positive, so the force is negative. The force is going to drive it to the left. If we displace it to the right slightly at a point x2, the slope is negative here. That means that the force is positive, pointing it to the right. And so we can see that both these forces from the slight displacements are pushing it away from the equilibrium. Therefore, it's an unstable equilibrium position. Unstable equilibrium occurs at the maximum on the graph. So now we can go back to the graph and identify these positions. So starting with stable equilibrium, this occurs at the minimum points, which is going to be x1 and x3. And then we can look at the unstable equilibrium points. These occur at the maximum, so that's going to be x2 and x4. And so how can we think about this physically? For a stable equilibrium, an example in real life is like a spring pushing back and forth between the equilibrium position. Going to oscillate between these two positions, xa and xb. Take the energy to be like so. We can draw a line through the graph. The point on the left side is going to correlate to xa, and the point on the right side is going to correlate to xb. Then for unstable equilibrium, a real life example would be like a ball on top of a bowl. If we slightly displace it, the force is going to push it away from this equilibrium position.